So what I need you to remember is that every system that we have literally is just a point. Now when we solve a system, we need an x or a y. And all we're doing is we're just solving for our system. So before we would just solve for y to get an equation, this time we're going to take two equations with two unknowns, exactly two unknowns, like an x and a y, and we're going to solve it. So in this instance, we're going to label the first equation 1 and the second equation 2. Now, when we go and solve for one of our equations, we try to use the simplest solution. So we solve for y for the second one because y is already linear, so we're good to go. And now that squiggle sign that you see really means that it's a system. Now you'll notice as I go along, I always rewrite my system numbers. And then I sub my second equation into my first equation, And you'll notice that I now have 3x minus 2 bracket negative 4 x plus 7 equals 8. And you'll notice I'm highlighting the minus 2. You're going to take minus 2 and you're going to distribute into the bracket. And you're going to get the following result. 3x plus 8x minus 14 is equal to 8. So now we have to collect like terms on the left side. And we're going to get 11x minus 14. Now we just move the minus 14 to the other side, and we get 8 plus 14 is 11x. And then we add those two together, get 22, and we have 11x is 22, and we find x is 22 over 11, which means x is equal to the value 2. Now, we need to find the x value. So we're going to go back to our second set of equations, and then what we're going to do is we're going to let y equal the original equation, but we're going to sub x equals 2 into that equation that we rearranged. So I'll just punch it in. Negative 4 times 2 plus 7. We get our final answer of negative 8 plus 7, which gives us y equaling negative 1. Now, we're not done yet. Once we've done that, we have to state our final solution. Therefore, the solution is something. So, our solution is always stated in the form bracket x comma y to negative 1. Now you'll notice I'm always writing this as a point where we have 2 as our x and negative 1 as our y. Now what I'd like you to do is I'd like you to take a moment and do a quick check to see if this solution was correct. Now, normally if we were doing a math problem, I would tell you check before you state your final answer. So we practiced this yesterday, and what I'd like you to do is I'd like you to make sure that this system, 3x minus 2y equals 8, and 4x plus y equals 7, i.e. the original system actually works. Do your left side, right side checks, and I will show you the answer. So pause the video right here and we'll check. So now let's begin. So we want to check, we're going to check to see if, well, for our solution, xy is equal to 2, negative 1, to see if that works in our original equation here. 3x minus 2y equals 8. And what I want you to do is I want you to take the time to do the left side, right side check that we did yesterday. Just follow the pattern. So remember, we have our LS, which is equal to 3x minus 2y. I'll start with that, and you do the rest, and then I'll show you. Pause it here. You'll see that our left side, when we substitute, you'll notice we end up with 8. So now, let's do the same for our right side. And you notice RS equals. So now we say, since the left side is equal to the right side, therefore 2, -1 is a solution for equation number 1. And now do the same for equation number 2. Pause right here and I'll show you the solution. So we get something similar to this. So when the time comes, I'm going to ask you to check your solutions for certain equations. You're going to get one more problem that has that.